Hi, everyone. I'm Joey D'Antoni, Principal Consultant at Denny Trade Associates Consulting, and today we're going to learn about building API apps on Azure SQL Database. There's a cool story behind this presentation that I'll walk you through, but this whole thing is kind of centered on a lot of interesting Azure decisions that I made, but a core Microsoft project called Data API Builder that we're going to talk through and share and demo. So this is going to be demo heavy. Chime in with any questions in the chat. I'm happy to answer them while I'm talking because we're going to go to a few different places to talk about things in this session. So that's me. I'm a Microsoft Data Platform MVP. I'm a VMware expert currently. I don't know if that program is going to continue to last as the VMware merger has continued to happen. Like I mentioned, I work for DCAC. You can find me on Twitter and Blue Sky. I'm at jdanton on Twitter, at joeydantoni.com on Blue Sky. I occasionally blog at joeydantoni.com, and I have a monthly column at redmondmag.com. All right, so if you're a DBA or a sysadmin, you might not necessarily know what an API is. So I stole this definition from Red Hat's website today. I had to pause there to not say Redgate, our lovely sponsor today, but it was definitely Red Hat. API stands for Application Programmatic Interface, which is a set of definitions and protocols for building and integrating application software. And what you're looking at in that screenshot there is the output from an API, which in most cases nowadays is going to be in the format of a JSON document. One of the reasons why JSON has become so popular in recent years is so much of the world runs on top of what we call RESTful APIs. And REST APIs allow applications to just kind of talk and exchange data in a consistent fashion. So why this session? This started out, and I'll tell you the story on the next slide, but I really wanted to get a list of all the Azure VMs sizes and their specs. So I decided to build an application to do this, and I'll explain why on the next slide, like I mentioned. But the other thing that's cool in this session, we're going to talk about the various Azure components that we built this on. So there's a bunch of things like automation, logic apps, web apps, Azure Container Repository, Azure SQL DB. And we're going to talk about how all those work together and how we kind of built out a security model here too. So in addition to being kind of a neat application, this is also something that's pretty secure. And the other part of this that's really cool is Microsoft built a pretty slick tool for building APIs against Azure SQL, as well as other data sources like Cosmos DB, MySQL, Postgres. And it's kind of funny, I work with one of my clients has an application development team, and they were talking about how they were trying to build out an API tool for some of their databases, and it was taking them 6 months to a year to get something off the ground from the ground up. And here with Data API Builder, we get 2 lines of code, and we can define how it works and how the API is built, and it queries our table effectively, and it's really, really easy. And I just want to state, I'm not a good developer. I'm pretty good at scripting things, but when it comes to actually developing software and worrying about dependencies and libraries and things like that, I'm pretty terrible. So I was able to get this working in a hurry, and it's something that I think anybody who's got any sort of development skill can integrate into an application quite quickly. So some of the Azure technologies we're going to talk about and demonstrate today, and I'll walk through each of these. Automation. So Azure Automation, if you're not familiar, is a way to execute kind of arbitrary Python or PowerShell code in the context of Azure. In this case, a lot of what we're doing, we could almost do this entire data flow in Azure Automation, but that wouldn't make for a very interesting presentation. So we're going to use some other tools. We're storing the data in Azure SQL Database. That's going to be our backend repository. We're also using Azure Logic Apps. Azure Logic Apps are a low-code solution. If you're in the BI space, you may be familiar with Power Automate. Logic Apps are somewhat of the Azure version of that component. Next, I have a bullet that I should have updated, but I did not, because I'm still clinging to the old name of Azure Active Directory, which is now Microsoft Intra, which I understand the reasons behind the name change there. From a marketing perspective, they're just wrong. And then Azure Container Registry. So one of the kind of interesting things here, we're going to build a container deploy that container to Azure, and that's what's going to run our website. And then finally, we're using Azure storage in a couple of different ways. So we're storing some data in Blob storage that we're ingesting into a SQL database, but also our container has a dependency on a configuration file that's going to live in Azure file storage. And that's the way we make that work. So that's everything we're going to use, I think. And there's probably one or two more things that I'll talk about when we're going through some of these demos. So how this project started, if you're not familiar, there's a Microsoft Azure subreddit. And I was home one day in January, and it was rainy and cold and dark. And somebody had posted to the subreddit about, hey, is there a single command that can give me the list of all the Azure VM sizes and their attributes? And I'm like, surely there's some PowerShell thing I can run to get this all in like one command. Well, about 2 hours later, and maybe a beer or two later as well, I was like, what the hell? I'm stuck. I couldn't figure out how to get all the data. So I texted Rob Sewell, who was still up, and he helped me kind of complete this code. And it is a little bit messy, and we're going to walk through some of that code. But we were able to get all of the VM data into kind of a single set of data, and I'll talk through that because there's a couple of unique caveats to that. So let's just go right into the PowerShell, and I'm just going to jump into the Azure portal, and we'll go into Azure Automation. Pro tip that I like to always talk about here, the easiest way to navigate the Azure portal is to type into the search box at the top. It lets you navigate kind of quickly and easily. So here I have this automation account called Demo for VM Sizes, and I have a couple of run books here. And I have this run book called VM Size. And I'm just going to grab this data and toss it in VS Code real quick, so it'll be a little bit easier to present with. And we'll make this a little bit bigger. So there's a couple of things that are kind of interesting here. So let's just go ahead and connect to Azure. So in lines 1 through 15 here, I'm actually connecting as the identity of my automation account. But I'm going to go ahead and connect AZ account in my code session here. And you're going to see a lot of messages because I have way too many clients. In the command I wanted to run first, just to show you, because this one's kind of weird. Doesn't really depend on me being authenticated. I just need to be connected to Azure. So if I do get AZ location, this is going to return a big list. And I can see all of these regions. So I'm going to just do a little bit of PowerShell magic here, and I'm going to say $location equal that, and then .name, because this will show you the data problem, the first data problem that we encountered. I shouldn't type in a demo, but I'm doing it anyway. Now, if I type location, I'd put that variable. Never type in a demo. Basically, what I wanted to show you is that there are a bunch of Azure Azure locations that come up in this get AZ location command that are not actually regions. So here, let's just do this because I know this code works, and we'll say where region type not equal physical. So you can see all of these things that come back as Azure locations: Asia, Asia Pacific, Australia, global, India, Japan, South Africa, and some of those actually kind of look like regions. So what happened is Microsoft made some change on the back end to the API. Get AZ location used to just be a guaranteed list of regions. It is no longer. So if I flip that around and make it equal physical, this will now give me a list of Azure regions that are available. So we need to have this data because we have to, because the VMs that are available in each Azure region are slightly different. So we have to loop through each of the regions, and that's what we're doing here on line 38. And then we're creating another object called VMs, and we're getting the AZ Compute resource SKU where the resource type equals virtual machines. We then have to loop through each of the SKUs to get this information about vCPUs, memory, uncached disk IOPS, max network interfaces, etc. And then we can output those results. So this is like way more complicated than I thought it was going to be. I thought there'd be just some command that would be like this, that would give me all of the resource information. As you can see, that is indeed not the case. So to get all of the resources, we have to loop through each VM type and spit all this back out. So what we're doing in the code, I'm converting that to JSON for simplicity's sake, and we're then writing it to an Azure storage container. So what this process does, it outputs to an Azure storage container called demo logic app VM size. And you'll note here we're using a connected account. And let's kind of start to dive into the security of this, because one of the things that we did, or I did, I should say, when I was developing this, was decided that I was going to use kind of good security practices, because a lot of times when we're hacking something together like this, we just do whatever and we just make it work. And then we try to figure out the security later. And that's something that doesn't really work too well because it's hard to do security after the fact. So one of the things that has been introduced recently to automation and a lot of other services is this concept of system assigned and user assigned managed identity. Identities are in Azure concept that if you've used Active Directory in the past, they're very much like a service account, except they're closer in reality to a group managed service account where you don't have to worry about the passwords. So theoretically, this identity has some kind of password on the back end, but I don't know what it is. I don't have to worry about creating a secret if you've ever created an application in Azure Active Directory. I just have to give it this identity. And then I can go into, for example, since we're writing to a storage account, let me make sure I have the right one, because the one thing I didn't do was configure this well. So that is the wrong one. Actually, I should just look at my code, because then I can see the name of the storage account I'm going to, demo logic app VM size. So if I look here under access control on my storage account, I can see the role assignment. Some of these are going to be inherited from my Azure subscription. But here I can see the application has demo for VM sizes, which is my automation account, has storage blob data contributor, which means it can read or it can write into my storage account. So the way we do this refresh process is this automation runbook runs. Let's just walk through that kind of real quick again. So just to walk you through everything that's going on here in automation, we're first connecting to Azure as that identity. Whenever you run an Azure automation runbook, you have to connect to Azure. And then whatever that identity of your automation account is needs to have certain privileges. The first thing we're doing here is going to resize the database, because I run this. If anybody's familiar with the SQL database sizes, and we'll talk about that here in a bit, I run this typically as an S0, and it works fine. That's a database that costs about $10 or $15 USD a month. However, when you're trying to ingest a whole bunch of JSON data, that doesn't work real well. So we upsize it to a P4, which is something that costs on the order of $1,000 a month, but we don't want to run that all the time. So the reason why I do this at the start of this process is because it takes a little while. And so while we're looping through each Azure region to get our information about the VMs, that database is resizing in the background. So by the time we get to the point where it's done, it'll be ready to go. So we go through each region, and then we have a process that says region processing is completed. You'll notice I have some additional code here on 75 to 78. I'm creating an additional Azure Blob storage blob in a different container that is just called status. And I'll explain why we did that in a bit. So just remember that. Hop back into PowerPoint. So we have this data. So now what do we do? And this is something I'm not the most proud of. I'm a DBA. I've been a DBA since I was like 12. And I've been a DBA for a long time. And I had to do bad things in SQL Server to make this work, or in this case, Azure SQL Database. And I'm going to justify the bad things I did here, because that's what we do. It's rationalization is the first step. Something about 12-step programs. This event might need a 12-step program. You'll note I'm going to authenticate as joeadcc.com. I'm also using a managed identity there. I have a bit of code here called populate VMs, and let's just grab this and we'll paste it into Data Studio so we have a little bit better view. I didn't do this, and I would always do create or alter, but SQL doesn't spit back create or alter. So you always want to use create or alter in your procedures. So at the beginning of this process, I delete from my VM sizes. There's a reason why I don't truncate that I don't remember. But as you can see, starting on line 17, I'm doing the thing all DBAs tell all developers never to do. Yeah, I know I'm not connected. On line 18 or line 20, I'm creating a cursor for this. And then I'm looping through, because remember, we're reading a file for each region. And the reason why I had to do this is if I was using SQL Server with Polybase, I could define a folder and just read all the files from that folder. The way Azure SQL Database works with blob storage, you have to define a specific file to ingest it. So I couldn't just like say loop through this folder and do all the files. So I kind of had to do some looping operation. You'll note I also could have done this in like PowerShell using DBA tools where I loop through each region, but conceptually it's the same thing as using a cursor. And I was knee deep in T-SQL at that point anyway. The other thing I have to do that's gross is within my cursor, I'm using dynamic SQL because we're creating a variable for the region, for the file name. So each file is going to be my region.json. We're then ingesting that, and then we finish. We do an insert from a temporary table, and then we confirm the load status. So this is not the best T-SQL I've ever written. I am kind of limited by my choices as to what I can do here. So this provides, this gets us our database, and this is how we get the structure in place. Obviously, since this data is JSON, you could use Cosmos DB if you wanted to. I'm not a Rockefeller, like I can't necessarily afford Cosmos DB on my Azure sponsorship subscriptions. I kid about the pricing of Cosmos DB, but at the same time, I don't. So we ingest that data from there, and we're going to walk through all this. So let's talk about automating this process. So let's start to dive in here and just talk about Data API Builder a little bit. So this is a Git repository. You can find the Git repository here. It's also well documented, so it's in docs, but it's under GitHub/Azure Data API Builder. I cloned this morning, but I didn't rebuild it. But I want to show you the most important part of this. So we have this file called dabconfig.json. And here you can see I'm using a connection string, and yes, I'm using a password. The only reason why I'm doing that is because this part of this runs locally, and so I have the password embedded. It's hard to do any kind of other command. On the Azure side, we'll show how this works, and we're not using a password. We're using a managed identity. But there are two key things here that I want to kind of showcase. So here we have REST API enabled. That's true. We also have GraphQL enabled, and that's GraphQL is kind of an interesting approach. And then we have these entities, and these entities are what define our API. So we have VM sizes here as a table. And we also have a view that's defined, and it's called demo view. The reason why I have a view here is I was doing this presentation, I think in Atlanta, and somebody asked about, could we use a view in this? Because you can also use a stored procedure, and I didn't know, so we tested it, and we did. So I'm gonna go ahead and run this locally by issuing this dab start command in my console. And we can see it starts. And lots of fancy information. So let's pop over to Postman. Postman is just an API app. And let's hope this command runs. You can see the output of my earlier efforts. So here we can see we have some information about our VMs. And I can filter this using various API strings that I append onto the end of this. But I just want to show you what this looks like on the application side. We can see that this request was received. We have an authentication. It issues a query for select top 1,101 records, include null values. And then we can just kill this by hitting Control-C. So that's the easy way to run that. The way we're doing this in Azure is to have a lot of fairly complicated things. So let's step back and talk through my Azure configuration here. So we start out with this automation account, right? So we have this automation account, this runs. Automation accounts have schedules. Excuse me. Automation runbooks have schedules. So a runbook in automation is simply a unit of work. We can tie a schedule to that. Here you see I have a weekly schedule, and my next run is, fortunately, it's in 8 hours. I don't know how I landed on running Wednesdays or Thursdays at 2:17 p.m., but it was probably some testing thing because this does run weekly. So there's a schedule there. One of the things I wanted to do was trigger this ingest process when that data ingest from the Azure API was complete. So you may ask, why do we need to run this more than once? Because you'd think all the VMs in Azure are never going to change. VM availability changes all the time, and the VMs that exist change all the time, especially in a per region basis. So this was something that was created in version 0.1 of this app, and then I fixed in version 0.2. When I first built this, so there are a number of ways you can do the thing I'm doing here. So what we're doing basically is triggering this logic app to run a stored procedure and then run another automation runbook when a blob is added or modified. You could do this using Power Automate. You could do this using Azure Functions. I don't like Azure Functions because I don't like writing real code. I have to import libraries and stuff. I can build a logic app within this GUI in about 10 minutes. Power Automate has a really screwy licensing model, and I have to switch over into Microsoft 365 land. So we landed in VM sizes logic app. So when I originally built this, and by the way, this V2 is their V2, not my V2. When I originally built this, I was like, oh, I know what I'll do. When a new file lands in that storage account, I'll trigger the stored procedure to do the ingest. Well, the first time I did that, my database CPU immediately shot up to like 100%. And I got all these blocking problems, and I got all this duplicate data, and I couldn't figure out why. What turned out, since I was triggering on each new blob that was added or modified, and I was creating a blob for each region, this logic app was executing 53 times, since there are 53 Azure regions. So that was not going to work. So what I ended up doing was creating this additional container called status. And what the status container does is at the end of that looping process, I write a file into a container called status, and it triggers it. This is kind of a useful technique because there's no real way to trigger things based on storage, no matter how you go about it, whether it's a function or a logic app or a Power Automate on like a specific file landing. I just, to give you another reference, I had to do something like this for a client recently where I'm backing up all of their databases to blob storage. And there's no way to say when the last file hits. So I created a SQL agent job using Ola Hallengren's code that backs up all the user databases I wanted to blob storage. And then as a second independent step, I use the same technique where I have a status container and I back up model for it. You may ask, why did I choose model? Model's always small, and SQL Server has to have model available to start. It was a hacky way to do that, but it was a server that I didn't have operating system access to, but I did have SA access to, so I couldn't do anything better than this. Here, though, I'm triggering, and just to show you the other aspect of this, I'm connecting to the storage account as the system managed assigned identity. This logic app, once again, has its own identity, just like our automation runbook had its own identity. So we're going to, get rid of that, and then we're going to execute a stored procedure. One of the things you should know when you're building a logic app, even if you're using Azure SQL Database, all of the tasks associated with Azure SQL Database show up in logic apps as SQL Server. It's a weird, dumb naming thing, but it is something that you should keep in mind. So here, once again, we're connecting as our system managed identity, and we're executing a procedure called populate VMs. So if I look in my database, and if I go over to database principles, I can see all of these applications. So I see logic app VM size DB API, VM size logic app. All of these show up as external users, and you'll note they don't have the UPN of dcac.com appended to them. They only have they just show up as an external user. So there's no real specific way to identify them other than that they exist, but you can use those to limit permissions. The other, one thing I want to tell you, they're a little bit hard to look up in Azure, and I'm going to have to navigate away from here for a second and elevate myself to global administrator because we believe in security at DCAC. This feature, if you're not familiar, is privileged identity management. It allows you to operate most of the time at a lower level of privilege than you have, and to temporarily authenticate to or escalate to a higher level of privilege. And my privileges are pretty low without it, so I can't look at users in Azure Microsoft Intra, excuse me. And this will refresh the browser and give me a new browser token. So if we go down here to Intra ID, this is not the most intuitive place. So this part of the Azure portal could really be improved. So you'll notice I clicked on Enterprise Applications. And if I click on Application Type, I have a choice of Enterprise Applications, Microsoft Applications, and then Managed Identities. We want Managed Identities here just to see what we have, but they aren't the most, flip that sort around. It's not the most intuitive thing. So I have 3 or 4 accounts here that are related to this app. My automation account, my logic app, my storage account, but they all have managed identities. And this is how we're doing security across all of these things. So we're populating the VMs. And then finally, the last step of this logic app is I have another Azure automation runbook. And this is doing a runbook called cleanup, and we're saying we don't want to wait for the job. So we're going to kick off the cleanup job and then go away. So if I pop back into that automation account, Oh, wait, I think I turned on my camera. Okay, there we go. That should be back to normal. Sorry for showing you my ugly face twice. I have another runbook here called Cleanup, and that's what that logic app is calling. In here, this does two things. So we resize the database back to an S0 so that it doesn't cost DCAC $1,000 a month. And then next we go through the storage container and we remove all of the files we created. So what we can do, just for a demo, and because we're good on time, we'll go ahead and do a data refresh here. And I'm going to use the test pane to do this. And if you haven't used the test pane, it's kind of fun and exciting. So one of the things about automation is it triggers like kind of a background job, and this will run in the background and wait for shared compute resources. So this is one of those things people like to call serverless, that runs on a server. And when this job starts, we'll be able to refresh job streams. Do we have any questions? If you want to drop them in chat, go for it now. Nothing so far. Okay, cool. So here we can just see that we're connected to Azure. This hasn't done anything yet. Microsoft is warning us about some breaking changes they're making to the set AZ SQL database commandlet. So if we pop into our storage account, one of the things we can do there is see the data as it's coming in. And we have nothing yet. While that's running, I'm going to go back into my PowerPoint slide and talk about the data API builder. So the data API builder, we talked a little bit about, and you kind of saw the config file, but it supports a number of different tools. You can support a relational schema or a GraphQL schema. So in the context of Microsoft land, this means we can use it against pretty much any relational database that's supported in Azure. I haven't tested it, but I don't see why it wouldn't work against SQL Server, not necessarily just Azure SQL. In the app side, it does an in-memory schema extraction. And it supports both RESTful methods like get, post, and things like that, as well as GraphQL. And the GraphQL piece of this is really kind of nifty, and it uses a tool called, because of course open source names are all stupid, Banana Cake Pop. And we'll do a demo of Banana Cake Pop here in a second. But let's get pop back in and just check on our status there. Okay, so our database is resized. Let's see if we have any data yet. Not quite yet. But we can also see that our database is now a P4. So we can see we have our first blob here, and I'll go ahead and download it just so you can see what the raw data looks like. So this isn't that sexy, but it's just a list of all the possible Azure VM types that are available, for example, in East US. And we see that the information we're pulling down, the things that are most interesting to us as DBAs are typically this memory and IOPS number. But what's going to happen is as this data processes, we're going to loop through each of these Azure regions, and we'll eventually process all of this data, and it will get adjusted into our database when that's complete. I mentioned banana cake pop, and you can kind of see this here. So this is GraphQL. It kind of looks a little bit like SQL conceptually. Here we have a query looking for VMs in West Europe with greater than or equal 32 CPUs. Let's go ahead and change that to 16 or 4. And we're going to say memory with greater than, say, 100. And I'll drop down the IOPS number a little bit there. And then we'll go ahead and run this. And we can see the various VM types that are available. And they're all way greater than 4. But we can mess with this to return different items. So we can say accelerated networking. So there we can see all the VMs that have accelerated networking are true. By the way, one of the things you'll notice since we're doing this refresh job in the background, my database is a P4, and you can see my query history here. It was taking 4 seconds against my S0. It's now taking 335 milliseconds against my P4. And one of the things that's kind of interesting is I think this database is in like West US or maybe East US. And I'm sitting in Germany right now, so most of that is the latency to go back and forth between there. So if we look at our job streams, we can see basically what I did was in my code, I put which region is completed as it completes. So this is going to go through the process of looping through each of these regions. You also notice that I hosted that. So I popped into that banana cake pop. And if you notice, the URL here is vmsizes.dcac.com GraphQL. So we also used Azure resources for this. And we used here app services. And this is vmsize DB API. This is an app service plan. And a web app. So this is a web app that's a container-based web app. So that means what I'm doing is I have an image deployed to the Azure Container Registry. This Azure Container Registry is, I don't know what I did there, but I clicked on something. JoeyD API, azure.cr.io. And so I can just simply, to update this app, I can simply just publish a new container to that container registry, and the app will automatically update. This app has a custom domain, and we can see monitoring, so we can see the metrics that we've been using it. And if I look in configuration, I can see all of our various Docker registry passwords, the URL, the connection strings that are associated here. We also have a path mapping, and this path mapping goes to Azure files. So we have a storage account called JoeyD DB API. So if I go there to that storage account and then file shares, we see we have one file here, and it's that dabconfig.json file that I showed you. Remember, it had a password in it? Now it doesn't have a password. So our authentication is just Active Directory MSI. So it's going to be the connection of our, everything else about this JSON file is the same. We can see our entities. In this case, it's VM sizes. I don't have the view here, but everything else is the same. But this is our configuration. And the reason why we have to have this, just in case you're not super familiar with containers, our container doesn't have any storage that's associated with it to persist the data information that we need. So in this case, we need to have some config data. And since we don't have that, we need to store that somewhere. And we're storing that in Azure File Services, which is one of the few ways you can store, you can persist data to a container. So when this container comes online, it's always going to be looking, and if we go back to that configuration page, it's always going to be looking for this path mapping. So inside of that container, it's going to mount /app/config as that file. And that's going to allow us to show that configuration. So this is all running as a service. Like everything else, this has an identity, and this is what's actually connecting to my database when we run queries. So this has the permission to execute the procedures that we're calling or read from the table. And let's see how we're doing here. Hopefully we'll be close to the end soon. I see a lot of, there are a lot of Azure regions nowadays. So one question that you may ask is, couldn't I have just like ingested this data into Azure SQL from automation using DB tools PowerShell? The answer to that question is yes, but it would have made a much less compelling demo. So we used logic apps and kind of cross some things up that way. So if we pop back into the database, we should be able to see when this workload is going to commence. So you see this is a P4 that I'm probably not using much of right now. As soon as this ingestion starts, just to give you a point of reference, this ingestion on an S0 takes about 12 minutes. When we bump the database size to P4, it takes about 11 seconds. So it makes a pretty huge difference. We're now into Germany North, after France South process, Norway. I don't know the order that Azure the API like pulls back. It seems somewhat random. Feels like there's a good World War II joke in here somewhere then, but France is ahead of Germany, so probably not. No offense to any French people on the line. I really like your country. Just pop back over to the slide deck and make sure I didn't miss anything. So the cool thing is you can do this, this API builder, you can run it locally, you can run it as a cloud service. You can do just about anything you want. So moving this to Azure, I wanted to make this more persistent. So like when I started out with this, it was just a PowerShell script that was running locally. So that was why I decided I needed to move it to automation. Like once I got the PowerShell script done, I was like, hey, I need to persist this. How do I get it into a database? I mostly don't believe running my own databases on my own laptop anymore. So I tend to want to run them in the cloud or in a data center. So I wanted to persist there. I also wanted to make it a bit more secure. So I didn't want to be passing things around. So I had to make a lot of choices, and we've talked through some of those choices, but let's just kind of go over them a little bit more. So security, one of the things I wanted to mention, and this is something that I'll say as recently as probably 10 or 15 months ago, was not the case. Managed identities are pretty ubiquitous across the Azure landscape. And I know I've talked a lot about that so far, but I think it's something that is pretty interesting in terms of it's a really easy way to have secure authentication. You still need to follow best practices, like you don't want to grant more privileges than you need to grant to any of those accounts, but you do have the ability to be a little bit more secure in how you do things. So the Logic app is something else I really like, and it's a really easy way to develop code. it's not the most robust way. Like, you can definitely do more in an Azure function, but a logic app will allow you to kind of quickly build things, and you can use them to, especially in conjunction, if you're okay at PowerShell, you can use a logic app in conjunction with Azure Automation and PowerShell, and you can really build pretty powerful solutions pretty quickly. And that's kind of what we've done here. It's a little bit overly complex for demo's sake, but at the same time, it's pretty robust. So let's just pop back over and see if we're done. So we can see that Azure SQL Database doesn't have a refresh button in its portal menu, and that always annoys the crap out of me. So if we go back from that test, we see that was complete. If we pop into Logic Apps, we can see that executed. And our stored procedure took about 2 seconds to run. Let me make sure we still have data. And we do still have data, yay. So we got a clean data refresh. So that logic app ran, and then if we pop back into the database now, we'll see the size pop back down to, hopefully pop back down to S0. We can pop back into automation to make sure cleanup ran correctly, but it should have. Okay, so we can see that cleanup's running. So I'm assuming it's completed. So now that gave me just enough delay to do this refresh. And yay, our database is cheap again. We should see, if we rerun this query, our time should go back up to yeah, there you can see it went from 247 milliseconds to a second, which is perfectly adequate for my application. But there is definitely a difference in performance between those Azure SQL tiers. So the Data API Builder makes it really easy to build API apps with your databases. They support both RESTful API and GraphQL, which are two really popular kind of solutions with developers nowadays. Azure does offer a plethora of options for building applications. So this is one of those things that's probably, I'd say, the most challenging about working with cloud solutions. I mentioned the Logic Apps example where I could do the same thing with functions. I could do the same thing with Power Automate. There's probably 2 or 3 other ways I could potentially kick off that process and move through it. So that's something that is really important to have kind of understanding of. Is what are the differences between those choices? What are the security implications of how you decide to build those? What are the cost implications? Because everything in cloud has a cost associated with it. And being able to delineate the differences between those costs and why they matter and what's important is really kind of your role. So many of those solutions do the same thing. We don't have a whole lot of networking involved with this, but if you're involved in any sort of Azure networking, you'll know there's about 15 different ways that you can load balance applications, and understanding the difference between all of those solutions is something that's pretty important for you as a cloud architect. So knowing the differences between those solutions and how they work and how they function, that's where you can add value. The things I want you to take away from this is Azure Automation is a pretty powerful tool. It's not the most popular, I find, amongst a lot of developers anyway, but if you're a sysadmin or a DBA or a reliability engineer and you are really comfortable with PowerShell, it's a good way to do a lot of back-end stuff. You can even run PowerShell against VMs using hybrid workers. It's a little bit out of scope for this talk, but that's something you should know about. You should be able to use managed identities. You can use managed identities to talk to grant permissions into your SQL databases. And it's pretty easy to build these apps with Data API Builder. That's about all I have. Do we have any questions from the group? Feel free to ask anything about what you've seen. I left some time for this because you guys have been pretty quiet.